Hello everyone, myself Sravanthi, working as an assistant professor in the Department of Data Science and Cybersecurity in MLR Institute of Technology. Today our topic is annotated parse tree for simple declarations. So here we are going to discuss what is annotated parse tree, the definition of annotated parse tree, and few examples on annotated parse tree for simple declarations. So let us discuss first what is annotated parse tree. So we can also call this annotated parse tree as SDD of a simple desk calculator. SDD is nothing but syntax directed definition of a simple desk calculator or evaluation of an expression or annotated parse tree for the expression. We can call it as annotated parse tree or SDD of a simple desk calculator or SDD for evaluating an expression, annotated parse tree for the expression. SDD is nothing but syntax directed definition. Here annotated parse tree is nothing but first we are going to construct a parse tree, and for the parse tree where each node is annotated with the values of its attributes. Here when we are going to construct a parse tree, for each node there will be values are associated for its attributes. So that is nothing but annotated parse tree. We are constructing the parse tree, then after constructing the parse tree, we are going to allot the values, nothing but for the nodes, we are going to give the values of its attributes. The particular attribute, whatever the value it is having, that value we are going to give it to its attributes. So this process of computing, we are going to call it as annotating or decorating the parse tree. Okay, the total parses. The process of computing the attribute values at the nodes, we are going to call it as annotating or decorating parse tree. So nothing but annotated parse tree is nothing but first we need to construct the parse tree. After constructing the parse tree, we are going to allot the values to its attributes. For every node there will be, we are going to allot the values of its particular attributes. So that is annotated parse tree. So let us see one example for the syntax directed declaration. Nothing but syntax declarations. Simple declarations we can call it as. Here we are going to discuss about the annotated parse tree for simple declarations. Let us see one example, float x comma y comma z. Float x comma y comma z. For that expression, for that simple declaration, we are going to generate the parse tree. After generating the parse tree, then we are going to construct the annotated parse tree. So here productions are given and the semantic rules are given. So the productions are these are few productions are there. Based on these productions, some semantic rules or semantic actions are given here. So let us construct the parse tree. So here float x comma y comma z. So here first expression for me is d. The first expression we are having is d. So d produces t and l. D produces TL. So as D is my starting expression, starting production, so I need to take the D start symbol. So I am going to take D as my first symbol. D produces TL. So the next one what I am having here, I got here T and L. So what is the first expression in my declaration? I have float. So the T is having two productions are there here. T produces float and T produces in. But according to my expression, it is float. So I need to take here T produces float. T produces float. So the next one is L. So L. Here after float, what are the variables? X variable, X comma, Y comma, Z. So these are the three variables are there. So here L, there are two expressions, two productions are there for L. L produces L1 comma ID, L produces ID. I cannot take L produces ID. It can be taken only when I have single variable. Here I have three variables are there. So I need to take L produces L1 comma ID. So L produces L1 comma ID. L produces L1 comma ID. Okay. So the next again I have L1. So it is also a non-terminal. Again I need to derive it until I got the simple declaration. Until I got the declaration or the parse tree. Here I have L produces L1 comma ID. L produces ID. So I need to take L1 comma ID. L1 comma ID. The next one is L produces L1 comma ID. L1 comma ID. I cannot take this one. Why? Because I got four variables are there. So I need to take here directly the L produces ID. Because I have three variables. X is one variable, Y is another, Z is another. So there are three variables are there. So I need to end over here. So I am taking here ID instead of L1 comma ID. If I take L1 comma ID, I am going to get four variables. But I am having here only three variables. So how I am telling is identify points to a variable. So ID is nothing but X ID is nothing but Y, ID is nothing but Z. Okay. So now the traversing, nothing but now this is about the parse tree construction is completed. Now let us do the annotated parse tree. So annotated parse tree is done by from the top to bottom. So it is done from top to bottom. From D to L, there is no reduction. It comes here, float. So it comes here, it goes to the backtracking and T. So what I am having here, T produces float. So what is the production I am having? Semantic rule. So T dot type is equal to float. T dot type is equal to float. T dot type is equal to float. So it is reduced. T dot type is equal to float. So it comes here. It comes here. I have X. X. There is no reduction for it here. So ID. There is no reduction over here. So it comes here. L1. So here what I am having here? L1. So L1 dot in. L1 dot in is equal to L dot in. L dot in. Comma, ID, nothing is there. Here there is no reduction. Y, there is no reduction. Nothing but there is no semantic action to be done. Here it comes. Here what I am having, L1 dot in is equal to L1 dot in. L1 dot in. So it comes here. Z. Here what I have here, L dot in. So L dot in. So what I am having here, L dot in. So D produces TL. D produces TL. So TL is nothing but here L dot in. So L dot in is nothing but I am having T dot type. So in is nothing but here inherited attributes. Inherited attributes. What inherited attribute does is it takes the values from its parent node or sibling nodes. So L dot in is equal to T dot type. T dot type is nothing but the sibling node. Okay, so T dot type is having here is float. L dot n is equal to float. Next, it comes here. L dot n is equal to L dot inherited. Nothing but it is taking the value from its parent node. It is taking the value from its parent node. So it is coming with, it is updated to float. Next, it comes here. L dot in is equal to L dot in. Nothing but it is taking the value from its parent node. It is taking the value from its parent node. So these are the reductions that are there over here. So this is of simple declaration for float x comma y comma z. So let's go for the next example, int a comma b comma c. Int a comma b comma c. So here these are the few productions are given here. Productions and semantic rules or semantic actions are given here. So let us take first one is D. So D is my start symbol. So D produces T L. D produces T L. So here T is there. So there are two productions are there. T produces int, T produces float. So according to my expression, it is int. So I need to take the second one. So T produces int. T produces int. So the next one, L. So there are two productions are there here. L produces L1 comma ID. L produces ID. Here according to me, here I am having three variables are there. So I need to go for these expression. So L1 comma ID. L1 comma ID. One ID I got, one identifier C is completed. So next I am left over with two variables are there, A and B. So again I am going to reduce this L1 comma ID. L1 comma ID. So one identifier C I got, one identifier B I got. So next I can reduce this L1. So there are two productions. I am not going for this fourth production. Why? Because this is completed. Here I am not having, I am ending only three variables are there. So I am done with two variables. I am left over is one variable. So directly I can take this identifier. L produces ID. L produces ID. So what I am having here? A. Identifier is A. Here it is B and it is C. Identifier int A, B, C. It's completed. Now this is the parse tree we have constructed. Now for this parse tree we are going to generate the annotated parse tree. Nothing but for the nodes we are going to give the values of its attributes based on these semantic actions. So it is starting from top to bottom. It comes here, it comes here, it comes here. Int is there. Again it goes here. Int, there is no reductions are there here. T is there. So T produces int. T produces int. What is the semantic action I am having? T dot type is equal to integer. So T dot type is equal to integer. T dot type is equal to integer. It comes here, backtracking. Yes, here what I am having here, L is there. L produces L1 comma ID. So but before that, this D is producing TL. D is producing TL. So nothing but L dot inherited is equal to T dot type. So inherited is nothing but it reads the values or it takes the values from its sibling nodes or the parent node. It takes the values from its siblings or the parent node. So L dot inherited is equal to T dot type. So T dot type is nothing but the sibling value is given here. So the T dot type is nothing but here I'm going to get it as integer. So it completes, it comes here. So L1. So L produces L1 comma ID. L produces L1 comma ID. So nothing but what is the action or the reduction says that L1 dot inherit is equal to L dot inherit. So L dot inherit is nothing but the parent node for this one. So it is taking the values from its parent node. So that is nothing but integer value int. Okay. So it comes here. L1. So L1 produces L1 comma ID. So it is producing this one. So nothing but L1 dot inherited is equal to integer. It is taking the values from its parent node. Inherited attribute is nothing but it takes the values from its siblings nodes or its parent node. Okay, it comes here. ID. There is no reduction here. There are no reductions. Here also comma, there are no reductions. B identifier, there is no reductions. Here there are no reductions and it completes. So this is of the annotated parse tree for simple declarations. Okay, so here what we are going to do is first we need to construct what is the parse. First we need to construct the parse tree for the given expression, and then afterwards, after constructing the parse tree, we need to generate the annotated parse tree. Nothing but for the nodes, the value of its attributes, we are going to give the values. So here the nodes are there. For that particular nodes, we are just giving the values of its attributes by using these semantic actions. If any calculation should be done, those calculations will be done and it evaluates the expression and it gives. But here it is of simple declarations. Okay, add it int a comma b comma c, a float x y z. So all this. So thank you.